Well, welcome back. We have a guest with us today, a senior corrosion engineer from BAPCO Refinery, Mr. Abdulrahman Al-Rumaidh. There we go. Hopefully I didn't totally butcher that. I tried it a couple times before we started here. So thanks for joining us. Greg, also here. How's it going, Greg?
Going great, thanks. Hope y'all are doing great as well.
Yeah. So this is a fun one. We've linked up here with Abdul Rahman because he has been pretty active on LinkedIn and interacting with us, and so we reached out and asked if he wanted to be on the podcast, and luckily he accepted. So we appreciate it. Thanks for joining us today.
No, so thank you for inviting me and for the opportunity to just chat and converse about the thing that we love, which is mechanical integrity.
That's right. And thank you, Abdulrahman, for being part of the inspectioneering community as well. We really appreciate that.
Yeah, I mean, inspectioneering is really one of the sources that I refer always back to. It's really insightful. It's not really technical, like same as scientific papers, but it gives you the philosophy and the concepts that drive the codes and the standards that we follow and try to comply with. So inspectioneering really is a useful resource.
Well, thank you. And we do try to help people understand why they're doing what they're doing and how to potentially do it better, or what all the various ways are they can attack a problem, what their benefits are, what their limitations are. That's very important to us. So for you and for everyone out there in the inspectioneering community, please keep your ideas coming, keep the articles coming, participate in the comment section for articles and so forth. We really appreciate that. So thank you.
We talked a little bit before, and I've obviously stalked your LinkedIn page a little bit. So you started out as a mechanical engineer, or I guess you are a mechanical engineer by education. What made you want to get into engineering to start with?
Well, I mean, I had interest in, let's say, crafts and dismantling toys and things since I was as a kid. So I think naturally I was leaning towards mechanical engineering. So I went to the University of Bahrain, which is our local university. I had a BSc in mechanical engineering, and it was really useful. One of the benefits that I got from studying as a mechanical engineer, maybe it's not the technical, the formulas and the way to solve a problem, but it's the skill on how to tackle an engineering problem. So how do you think about it? What inputs, what assumptions do you need to consider? What are the tools that you would use to think about a problem and solve it, hopefully?
Yeah, critical thinking skills. Yep.
Exactly.
You mentioned taking toys apart. This is where my brain starts going. What good stories would your family tell about something that you did back then?
Well, one of them was I torn apart a radio. I tried to see the internal components of a radio, and then my father saw the radio dismantled. I was like, what is this? So, but I was happy later on when I assembled the radio back again, and I could hear the white noise that it's not a radio anymore. It's not receiving signals, but at least that noise was satisfying enough. Yeah.
That's why you didn't become an electrical engineer, right?
Exactly. Yeah.
Yeah. Oh, that's funny. So when you were in school, were there any classes, were there any courses that you really gravitated towards?
Fluid mechanics, thermodynamics, the material science was one of the most interesting topics to me. And that are relevant to my profession at the moment. I didn't know that at some point my job will be to apply these principles and concepts, but here we are.
What was it? Because I took materials. I think everybody takes, right? You take a breadth of classes, and I always thought the materials classes were interesting as well. My school that I went to did a lot with semiconductors, so we learned a lot about like the silicones, the geraniums, the doping, and all that stuff. What was it about the materials classes that was interesting to you?
What we took mostly was about the metallic material science. So, we talk about the microstructure of material, the body-centered, face-centered structures of material, about mechanical properties of material. We delved a bit into polymers and ceramics and other types, but the main focus was on metallic.
Metallurgy.
Yeah.
That's great. Great stuff.
Exactly.
Yeah, it's a great pre-rack or a great starting point then for everything else. It's so crazy to me to think about, like, on the screen, they blow everything up and there's all that space. But, when you think about the damage mechanisms that we have and how hydrogen can somehow find its way into those little open spaces, it's crazy to me that it's that much smaller and that it can work its way in there and obviously cause bad problems.
One of the chapters that was in the textbook, I remember, was about corrosion. We didn't take that chapter part of the study, but later on, after I joined BAPCO as inspection, I went back to the textbook. So, and then I noticed that we had that corrosion chapter, and I was like, why didn't we take that part of the study? It will be useful. But anyway, I have the textbook, and that's one of the benefits of going to school and learning a topic systematically. Having a syllabus is that you get familiar with the textbooks and what resources you have. You can't learn everything and remember everything, but at least you have to know the resources that will be useful for you. So if you have a question, where should I go to answer that question?
You go to AI now, right?
Yeah, exactly. That thing is scary. It knows a lot. I think too much, yeah.
Is that called overthinking it? Is it? Abdulrahman, question. Were there any particular professors or instructors you had in school that come to mind that were influential in your career?
It's interesting because actually the professor that gave me that material science topic, one of the skills that he was insisting on learning was report writing. And he was, especially the first assignment that was given to us was, I remember I gave like 3 revisions for the reports just in order to refine the table of content, how I refer to references, how's the captions and, all the formatting and how to present a technical report. So till now, I remember this as one of the most beneficial skills that I got through school.
Yeah, it's also a discipline, I think, because most people I know hate to write reports, but they're important, and it does take a discipline to sit down and do that right.
Exactly.
Awesome.
Exactly, especially now with inspection and corrosion with failure analysis, that report writing is a must. So having that skill with you is really helpful.
So obviously one of the keys to writing a good report is to being a good communicator. How has that helped you in your career?
So I remember one of the skills I learned during school was you would write the introduction after you have written all the information that you're hoping to deliver. So that gave me a really beneficial skill in such that you would summarize the ideas after writing them. And before that, you have the table of contents. So you know what you are going to write about. Will give you some kind of guideline on what to write. And then you summarize what you have written.
Yes.
So again, when I'm writing now inspection reports, for example, it's really important for the writer to put himself in the reader's shoes. So how will the reader understand and how he will receive that information? Will it make sense for him when he's reading, or no, you need to explain something even further? Because when the inspector does the inspection, he saw it, he recorded, but he's the one who saw it. So you need to write the reports somehow in a visual way that will be comprehensible by the reader.
That's great advice. I love it. Very good. I remember in journalism class where for news stories, which is what we're talking about here, facts and so forth, that you tell the story 3 times in what you write. You tell it in the first paragraph, and then you tell it in the body of the story, and then you tell it in the conclusions. So anyway, that brings back some good memories for me
Mm.
from a couple of eons ago.
Yeah.
Surprised you remember that far back, Greg.
I'm just having one of those moments, you know.
On your game today. Oh, that's great. So did you do any internships or did you do any co-ops or anything like that
Yeah.
during school?
During school, I did an internship in the upstream section, the upstream sector. So I had a 2-month internship, and another one was in the dry dock for shipbuilding, which we have here in Bahrain as well. Yeah, and it's really amazing. I mean, when you go there and you see the ships and you see the scale of like massive components that they have in ships. Like I remember looking at the chain that is used to pull the ships into the dry dock, or to align it and to position the ship within the dry dock. And the single piece of the chain, it's so big that you can sit on it. It's really huge. And when you see the machining equipment, like the turning machine compared with the normal machining tools that we have, it's really massive. It's really interesting to see in front of you.
It's crazy how big those components are, and then you think about the machinery itself that can move all of that.
Exactly.
It's wild that somebody's like, oh, we're gonna make this big giant thing, and like, yeah, that's a great idea, and then you're like, but how do we make it move? How do we store it? And then somebody's got to figure out that problem as well. It's
Exactly.
yeah, engineers.
A question for you, Abdulrahman. When you were working in the shipyards and you saw these giant things, did it give you an appreciation at all for the importance of safety and how one little mistake could mean someone could lose their life, you know, and big things like that are so big? I mean, I imagine if that chain fell on a person, it would kill them. Or if something broke and things, you know, went flying, it could kill them, right?
Yeah.
I imagine
exactly.
safety was big there, as well as
Yeah,
in
exactly.
a refinery, right?
Yeah. I mean, yeah, like especially in the introduction or the induction to the internship, they will give us a safety induction. What are the PPEs that you need to have? What practices you need to follow while you are inside the shipyard? That was an introduction to me to safety and being vigilant and being careful, and be careful where you place your foot, where you place your hand, and so on. So yeah, it was an experience for me.
So what did you do there? What was your job?
Just to take notes, listen, and learn. Not much of a hands-on training. Yeah, I would say my first training, let's say in safety, was in BAPCO, like on-job training.
Mm-hmm.
Yeah, but after graduation from university, I applied for jobs, and the first job was in a contractor company for air conditioning. And then I stayed for around 1 year, and then another year in a governmental job. They were not much satisfying to me, so I kept on applying for jobs, and then I was blessed enough to get a job in BAPCO. And
Nice.
yeah, it was really... it is an enriching experience for me till now, and I hope it will remain that way.
So you mentioned doing a little bit of time in the upstream portion. Let me first start. Was it onshore upstream or was it offshore upstream?
No, onshore.
Onshore, yeah.
Yeah.
So we're not talking dealing with boats or platforms or anything like that.
Yeah.
So you know, talk about a little bit of the differences that you experienced between the upstream version of BAPCO and now the downstream version.
So first of all, the area. When you see the oil field, how massive it is, and that is one. Everything is carbon steel. The exploration part is interesting. My senior project, actually, university, was to solve a problem with the cooling of the drill bits while drilling oil wells, especially for high temperature, high pressure wells. So that internship in the upstream sector was helpful to me to learn and to understand how drilling works and how exploration works.
Yeah. So mentioning joining the company, when you started with downstream, what type of role did you come in as?
I was hired at the beginning in the inspection part.
Okay.
Yeah. So actually, that's interesting because I remember when I first joined the company as a trainee inspection engineer, I had zero expectation. I had zero expectations about my role as an inspector. I remember I went to the company all dressed up, wearing a shirt and a tie, and I went to the manager, and he was like, "You can leave the tie at home tomorrow because we're having a shutdown as we speak." Yeah, it was one of the turnarounds in the company for one of the process units. So it was a shock for me that I had no idea that as an inspection engineer, I would be working a 12-hour shift, like even weekends, the whole deal. So that was interesting shock to me.
Oh, so you started right at the beginning of a turnaround.
Yes.
Oh,
Yeah. So you can imagine the surprise I had.
Man.
Yeah. And even I remember in the interviews, some parents were being given like part of the questions, like would be interested in being a welding engineer or an inspection engineer. And I was like, no, I'm not interested. But then, part of the recruitment is that you will go through some interviews, some quizzes, some exams. Then they will choose the position that is fit for you. Luckily, I was selected in the inspection department. And I'm saying luckily because later on I grew to really be passionate about this field. It's really interesting how I started. And now really like when I come back home and I'm thinking about work and what things I can do on the next day. It's a really interesting position I am in. I'm really blessed.
Is your focus fixed equipment, rotating equipment, or both?
Fixed equipment.
And yeah, okay, cool. And within that, then, as a fixed equipment inspection engineer, what does a typical day in the life of Abdulrahman look like at BAPCO? A typical day.
Yeah, when I first started, as I mentioned, it was a turnaround, but later on, once things got smooth after the turnaround and we started writing the inspection reports, so that was interesting. And then we went back to the normal on-run inspection and on-stream inspection. So yeah, the normal day was to each day go to the process unit, have a chat with the operations team, look at what are the inspection activities to be done on that day, and trying to learn about the process unit. So I remember part of the training that I went through was to be rotated around the process unit. So starting with the crude units, with the FCCUs, HCUs, and so on. So that was an opportunity for me to gradually learn about the process and the operation of each unit that I'm exposed to.
What would you say the most challenging units are for you there? Trying to improve performance, reliability, keep them safe and running. Which units do you find the most challenging?
Well, I mean, in terms of sophistication and the design and the material selection, what the process parameters, what IOWs need to be maintained, I would say the hydrotreating, the hydrocracking units.
Okay.
Especially with the variety of materials that you have there, the different operating parameters. It's really interesting.
Yeah, I'd agree. The hydrotreaters, I find, I'm a chemist by education, and so I find those very fascinating, what's going on, especially around the mixing boxes and the hydrotreaters where you're injecting water into the stream, and you get all kinds of things going on at that point, right? I don't know if you found the same challenges there as well. They can get, a lot going on there.
Yeah, exactly. And something interesting that I came across when I was reading one of the books about hydrotreating is that when you see the materials of, for example, the air coolers of the reactor effluent. And I remember I saw one of the textbooks mentioning that it was made of carbon steel. And the one I see is made of like nickel alloys, like incolloy and hastelloy and these exotic materials. And I'm like, how did they used to manage with carbon steel in the previous days? Yeah.
Yeah, they probably inspected a lot more often and hoped they'd catch it before it leaked, right?
Yeah.
And then they allied up.
It's interesting to see how the timeline of things, how it goes, how it used to be designed, how is it designed now?
Yeah. Are you guys using RBI there, by the way?
Yeah, we are. We are developing the RBI programs for the process units. So yeah, we went through the DMR process about the data collection. We saw the challenges that could face us in that process to collect data with all of the challenges and data quality and so on.
Yep. Yeah. It's a very integrated process.
Yeah, it is.
I think that's one of the biggest things that I realized is how interdependent things are and how failures rarely occur because of just one thing, that there's usually a combination of things that happen. So can you give us an idea and scale? What size refinery are you working in? Is it 350,000 barrels a day, 500,000 barrels a day, 180,000 barrels a day?
Yeah, so now after the expansion project in our refinery, the production increased from 270 to 360
Okay.
thousand barrels per day.
That's a lot.
Wow.
Do you have a delayed coker there or continuous?
No, not yet. Not yet.
Okay.
Yeah, but we recently introduced the part of the expansion project, the Resid Hydrocracker,
Okay.
which I understand they're not much in the world. I think we are the 11th refinery to have a Resid Hydrocracker in the refinery. So yeah, that would be an interesting learning journey to have
Yeah.
this kind of unit.
Yes. What are the damage mechanisms you have there that are the most challenging, you think?
I mean, we have a journey to learn about more about the how it operates, what kind of damages we would expect to have there. But what I can see, I mean, now is that it's really similar to a hydrotreating unit.
Mm-hmm.
But again, as I said, like we are still learning, we are still trying to discover this kind of process. So yeah, it would be an interesting experience to have.
So do you have responsibility for doing like level 1 and level 2 fitness for service assessments in your role?
No, it's mostly part of the engineering department. They are mostly responsible for fitness for service. For sure, inspection plays a vital role in delivering the data and all the findings that will help the fitness for service. But as a responsibility is with the engineering group.
I just went down a quick little rabbit hole here on Resid hydrocracking. My mind's still working through the fact that you can take Resid and crack it to that level. That's online now? That was part of the project, or that's planned to come online?
It is. No, it is. It is. And it's really an interesting design how the reactor works in that Resid hydrocracker. It's not a normal fixed equipment. It has rotating parts. It has like some kind of pumps and a mixer in the reactor. So it's really interesting.
Inside the reactor has all of it. So
Yeah.
Huh.
High pressure though too, a lot of times, probably.
Yeah, exactly.
Yeah. Okay. Interesting. Was that the big piece that allowed for that level of expansion, or did you guys have some other debottlenecking as well?
No, we had like a new crude units, new utilities, hydrogen plants, hydrotreating, hydrocracking units, and the Resid hydrocracker is I would say, the pearl of that project. Yeah.
Did they involve your inspection team at all in any of the project work, planning, prepping, anything on the front end side of that? Did they include you guys at all?
Yeah. We have a team that was from our department that was involved in the project. So yeah, especially just to make sure that the project is going according to procedure, or the quality controls, or the documentation, the material reviews, the inspection task reviews, and so on.
Nice. That's good. A lot of times project teams kind of just take everything and plop it in, and here you go now. Inspection gets to figure out how to deal with it.
Mm-hmm.
So,
yeah.
Now from the corrosion standpoint, were you brought in, or were other counterparts brought in on specific material selection, or just review of what was picked?
Yeah, the material selection was done by the consultant, but as I said, the team that was involved in the project from our end was involved in reviewing the material selection and the design and the inspection plans.
Cool.
Yeah.
Cool. Nice. Yeah, so that had been nice to at least be able to I understand what the plan was going to look like. Because, right, I mean, 5 years from now, you're going to have a lot of inspections to do.
Exactly. Yeah. Yeah, I would imagine that would be a big challenge. I mean, it would be a big project to do the baseline inspection with all the tremendous amount of equipment that need to be inspected. It's a jungle. It's a jungle there.
Is it part of your responsibility to create inspection strategies or to approve them, review them? Or is that the inspector that does that?
It's part of the inspection team responsibility, but for sure, part of the failure analysis and the failure investigations that we perform, we revise these inspection plans according to the new findings and the new discoveries about the damage mechanisms that are expected. And those.
What are your thoughts, Abdulrahman, about, for instance, root cause analysis? Does BAPCO have a pretty robust process for that?
So in the RCA procedure, we categorize incidents based on the impact of that incident. So according to the consequence, there is a procedure that will determine who should be involved and how sophisticated should the investigation be. So if it's if of low consequence, maybe the inspection engineer or the process engineer would be sufficient to investigate and provide the necessary recommendations and the mitigation actions. If it was of something of high consequence, a multidisciplinary team would be formed to investigate and have the inputs from the different teams and go to each detail about the incident just to try to solve the issue from its root.
Yes. So the amount of rigor in the RCA is dependent upon the potential consequence of the failure.
Exactly.
Makes sense. Criticality based. I've always felt that a good RCA program is necessary to help us learn from, those incidents and then to implement what we learn appropriately. But it's also, I think, another way that it's a part of continuous improvement, right? We have different initiatives and programs, whether it's an RBI program or a high temperature hydrogen attack initiative or whatever. How do we gauge the effectiveness of those? I think RCAs are critical in helping to, for continuous improvement, because nothing's perfect, right? When you first implement, it's probably least perfect. And that's good, because I ask that question to a lot of people and I often get blank stares or I don't want to go down that road, but I love your answer. That's great.
For that reason, I mentioned that the Resid Hydrocracker will be a journey because nothing's perfect. We expect to find some surprises, some issues in the design. Maybe some material was not selected properly or some integrity window was not set up correctly. So having that kind of continuous improvement programs, having these RCAs, these investigations will be crucial to continuously improve on our strategies.
Right. And you mentioned IOWs on a scale of, say, 1 to 10, with 1 being we're just starting and 10 being we have a very robust, effective IOW program. Can you speak a little bit about your IOW program, how automated it is or isn't, and how well it's working?
Yeah. So the IOWs, I imagine with many companies, it's the same, that we developed part of the RBI study. So the RBI study was an opportunity for us to do that kind of process systematically, to go through the damage mechanism review and develop the integrity operating windows. So after those identification process, we set them up in our system, and it monitors the historian and the operating parameters, and it's able to send an automatic notification based on the excursions that you would expect. So when the corrosion engineer responsible for that area receives that notification, he would communicate that finding with the operator and see how things can be controlled better.
I see. Yeah. Who owns the IOW program at the plant? Is it operations? Is it integrity? Who owns the IOW program?
No, integrity. Yeah, okay. Integrity. So since the integrity team and the corrosion team were the ones to develop those IOWs based on their knowledge and experience about the plant, they are you would say, the subject matter expert in the topic. Yeah. So they are the most knowledgeable team to know what is the impact of that IOW excursion. Why was it put in place to begin with? What's the importance of that IOW? So it's really important that it's owned by the integrity team, but the most crucial part is the communication. So as soon as an excursion happens, that has to be communicated with the operations team.
Does it seem to be working well?
I think so. I think so,
Good.
yeah. I mean,
Good,
yeah, that's communication is working well. And it's good for the operator to understand how their performance in operating the plant, how it affects the equipment.
Absolutely.
And it's really interesting to see, even for us as corrosion engineers, especially after we developed the IOW program. When the excursion happens, you would see it firsthand, how that excursion affected the condition of the equipment.
Yes.
I remember in one of the cases where we had one of the overheads of the crude unit that we inject wash water there. Luckily, we had corrosion probes installed on the overhead. So for some reason, the pump of that wash water was having an issue. It was shut down, that pump. And we were able to see from the corrosion probe thickness readings how the corrosion rate changed after we repaired the pump and we put it back online. And it was really, really interesting to see how corrosion appears and how the relationship between corrosion and operation, how they are strongly linked together. You know, so some people think corrosion is just you doing investigations or you're doing inspection. But no, it's not happening in silo. It's happening in conjunction with everything else.
Yeah, the thermodynamics are phenomenal, I believe.
Exactly. Yeah.
Okay, I got a lot here. First question: how many corrosion engineers do you have at your facility?
Currently, we have 5 engineers.
5. Holy cow! Okay, and so each of them is responsible for a certain area, basically.
Yeah, exactly. Yeah. So just to keep a focus on their process, on the type of operation that you have there.
Yeah.
So that corrosion engineer will be specialized in that process. He would know the material selection for that process, what is the expected damage mechanism, and you look at all the failures, all the history of the equipment. So having that kind of dedication to the complex is really important.
Yeah, I've been to some facilities that have 0. And so to have 5, so that's why integrity can own it. That's why corrosion engineering can own the IOWs, that is, because there's enough to be able to manage all the readings that come out.
And the automation helps. So
do you mean?
having these, having our APM software
Okay.
that will monitor these excursions and sending these notifications.
Mhm.
Really helps the corrosion engineer instead of going to each unit and looking at what are the parameters that are exceeding my limits. Having that kind of automatic notification is really helpful to focus your energy and effort on the things that matter.
So have you been able to set it up where there's kind of a sensitivity where if it just jumps out the window for a second and back in, okay, we don't really care about that. Is there time limits? How have you set it up so you don't get, or how have you, whether it's how you manage your inbox or how do you deal with not being inundated with so many alerts?
Okay, so that would depend on the IOW. Some parameters we can live with an excursion of a couple of hours or a couple of days.
Yeah.
Some are not. Some are
Right.
more sensitive. So depending on the IOW, we have the policies that measure the duration of the excursion. And accordingly, it will decide to send a notification or keep it. Just record the event, but don't. It's not necessarily to send a notification.
Gotcha.
And that's based on the criteria and the situation, I assume, because I guess sometimes you're going to have human intervention. You're going to have a corrosion engineer review it. But at the first level, it has some criteria it applies for automation. And then based on passing or failing that criteria, then the email gets sent to the corrosion engineer to get involved at that point. Is that correct?
Yeah, the human intervention is a must. We cannot depend on the policy or on the automation alone. The human intervention is a must. So the machine is a helpful tool, but at the end, the corrosion engineer needs to look at the trends. You know, so he needs to look at the other parameters and how the interconnection between them, how one parameter affects the other. So you cannot depend completely on the tools and systems to identify issues. For sure, the human intervention is a must.
We can't AI that yet, right?
I hope so, but we have a journey to reach there.
Yeah.
Agreed.
Now going back to the overhead system there with the installed corrosion sensors, I've talked with sensor companies before, and they've shown me some of the plots. How cool was it to be able to pull up that plot and see not just like your standard point to point, like, oh, corrosion happens somewhere in between, but actually to see the line of the corrosion over the course of that period of time. Was it linear? Was it not linear? What did you think about when you were able to finally pull that data?
That was actually interesting because this was a recent project as well to install these projects. So after we installed the sensor for like a couple of years, and then we started downloading the data and analyzing them. So at that point, it was purely data. We were trying to look at the data visually, do some time series segmentation just to calculate the corrosion rates for each segment, each operational event. I remember when we did the analysis and we calculated the corrosion rate, how it is changing. And then we saw that a sudden reduction in the corrosion rate from a high to low. And then that was interesting. And then we started looking at the operational history. And when we placed the date that wash water pump was repaired and put back in operation, that mark came exactly on that sudden drop of corrosion rate. So it was really interesting to see. It's not something that you deliberately forge that graph. The facts, they speak to you, and the numbers, they speak to you. You just need to correlate the right parameters and the right information with each other. So having that kind of context, you cannot depend on the AI or the computer or the software to determine. You need an experienced corrosion engineer to form that context and ask the right questions. What parameters is affecting which?
Yeah. I mean, very well said. It's, gosh, you guys should do a presentation on that or something. You should find somewhere to get that out and be able to share with people how important, like, here is a real life, we've seen it, we were just happen to be measuring it, example of how IOWs, when, done well or not done well, this is what can happen. If you manage them, then this is what you get. And if you don't, you can see here, not that you didn't manage it well, you guys knew what you were doing with the pump being down, but if somebody were to allow their system to go out of whack, they would be able to see this is what could happen. It'd be
exactly.
Yeah, you guys should, if you haven't already. I know a publication place called Inspectioneering that you could probably put it out.
There are so many interdependencies. I know I've often looked at it like sometimes you pick up a rock and there's 5 other rocks underneath it. Sometimes you pick up a rock and there's nothing underneath it, or maybe one rock. And that's where the critical thinking skills and the education and the experience really come to light in their value. Yeah, we haven't AI'd that yet. So,
yeah, and speaking of like corrosion monitoring, it's really useful in terms of, and IOWs in general.
yes.
Like now I see one of the challenges that we have in inspection is in the confidence in data.
Mm-hmm.
So, okay, so we do the inspection now and we calculate the remaining life, the corrosion rate, and we know when is the next inspection day. But how confident are we that the data will remain relevant till the next inspection? Because maybe now the inspection findings tell me that I can leave the equipment for 6 or 12 years or 10 years. But what happens in between that window is a mystery. So having this kind of corrosion monitoring sensors, the IOWs is giving you that clarity on that blind spot. So it's no longer an unknown territory. You know what is happening and you know what to expect. If you need to revise your asset strategy or no, we are good. The data that we collected, let's say 5 or 10 years ago, is still relevant. So I believe this IOW program and corrosion monitoring will really, they are changing the game of integrity programs.
Yeah. Greg and I were just talking with somebody a couple months ago, and they made an interesting statement. I might have said it on here before, but if you had your IOW program dialed in, you were managing, you knew all of them, would you really need an inspection program? It was an interesting thought of like, right? Because it's that link, right, of operations into linking with inspection. If we have our IOWs, we have the DMRs or the CCDs, we know what we should be expecting, and we can keep operations in check. Then there shouldn't really be, as you said, there shouldn't really be any surprises. That data that you have, it should be valid until it's not, right? Until we have an event that causes it to not be valid, and then we go out and do the inspection to then update our projections. It was an interesting thought experiment that they mentioned.
It is an interesting thought. However, I see that the issue is, again, it's in the confidence and the maturity of the program. So we have the IOW, we know it works, but how confident are we? How mature? Do we know that we identified all the necessary IOWs? Maybe we missed out some. So, okay, we need to have that kind of, again, going back to the continuous improvement and the investigations. So we have the whatever IOWs that we have developed, and all of them are within the limits. But still, when we did the inspection next time, maybe we found some discovery. So we will again revise the IOW that we have. So again, it's the organizational maturity and the maturity of the IOW program, I think, that will develop with time. So I think, a time will come where we will be more dependent and we will be confident that what the IOW is telling us is giving us the right information. But I think we are not there yet.
Yeah, the scary part, right, is as it is with any new damage mechanism that we find, right? We don't know what we don't know. I think you said it well, right? If we miss an IOW because we don't know about it just yet, then yeah, that's why we got to keep doing the inspections. So,
Exactly.
Yeah. When I teach RBI training, I tell people, I say, if we knew the exact day that a failure would happen, we wouldn't be doing inspections. We would just be doing replacements. We would replace that section the day before it failed. But that's why we have inspection. We know what we think are all of our IOWs. We know what we think all of our damage mechanisms are, but it's that unknown, that uncertainty that we need to go out and still at least make sure that we have an idea of what we're looking for, and hopefully find something before something happens.
I think you just answered your question you asked earlier, Brad.
I know. The more we talk, the more I realize that, everybody kind of just throws CCDs, RBI, IOWs, they put them all together. But I don't know, at least me, it hasn't been until recently I really understand and see how they all support each other and how they all work together to really provide that really good foundation. So you mentioned going through RBI and going through data quality and the DMR process. If you were to go through the process again, would you maybe change how you go about it? Or is there any lessons learned that you thought, or anything interesting that came out of the process that you went through?
Well, I mean, one of the things that comes to mind is about the data quality. Data quality is one of the challenges that face many, many companies. Your RBI program is as good as the quality of your data, especially with the semi-quantitative analysis that you would have. You would rely mostly on data. So I would say trying to fix the data and try to improve the quality and how you collect the UT readings, the cracking inspection, the procedures, the qualification of the technicians, how you review the quality. So all the procedures. That would drastically improve the quality and the effectiveness of the RBI study.
Yeah, it does, right? I mean, garbage in, garbage out. I assume you have a written RBI procedure that you guys follow. I'm also going to assume that you have contractors help support you on implementation. Do you have them go through your procedure and make sure that they understand it?
You mean contractors for ND?
Yes. Do they understand what you're expecting from them so that your team can properly input that information into the RBI?
Exactly. I mean, so that is why the APM tool that we use, that RBI study is directly linked to the inspection management and the inspection tasks that are being generated or recommended by the RBI study. So when you have that kind of link, it becomes clear to everybody, including the inspection, the contractor, the technicians, That's why am I doing that inspection? So I'm doing some cracking inspection there. Why am I doing it? So when you go back to the RBI and you find out that the damage mechanism, for example, is what H2S, so you understand. When I'm doing, for example, automatic UT scanning, I understand that here I have some kind of localized corrosion. Maybe I'm taking a few samples of spot UT. Then I understand it's a general type of corrosion. So having that link, again, as you rightly mentioned, Brandon, that everything is interlinked. Inspection with RBI, with CCDs, with IOWs. It's a full process. It's a system that is integrated. So having that integration clear by systems, by softwares that clarify that interlink, and having it also clear by communicating with the different teams and the different parties that are involved in the process is necessary to ensure the success of the program.
Yeah. If you had Al-Rumaidh Refinery, what would be the first process, system, tool? What would be the first thing that you would implement to be able to provide a high quality integrity program?
I would say the damage mechanism review is the starting point for many, many processes. If you will talk about inspection programs, if you talk about IOWs, if you talk about where to place your corrosion sensors, what RBI study to perform, it all comes out from the DMR. So knowing what to look for, what to expect, that will drive everything you do after that.
Yeah.
I agree with you too.
Yeah.
I think whether you're doing RBI or not, you should do the DMR, right?
Exactly. Yeah.
Tells you where to look, what to look for, understand, again, the interdependencies or thermodynamics of the damage. Absolutely.
I think Clay White said the same thing when we had him on. I asked him that question. He said the CCD, the DMR, that's really the starting point for everything. Otherwise you're inspecting blindly or you're managing blind.
Yep.
Yeah, and like people have the impression that DMR is part of RBI. You don't need it for anything else, but that's a misconception about DMR. That everything literally depends on the DMR. So otherwise, you're just going blindly into the site and hope to find something with the inspection technique that you are using.
I would say the DMR is foundational. I don't know if you agree with that or not, but
of course,
it's foundational.
It is.
Interesting. I want to back up a little bit here. So you're a mechanical engineer. You came in as an inspection engineer. What was it that made you take the jump or the leap over to corrosion from the inspection side?
Yeah. Again, I was blessed and privileged to have that kind of rotation training. I had the privilege of wearing many hats. So I worked with the inspection, with the failure analysis, with the MTC material testing certificates review, with the contract development, with NDT planning, and then RBI and corrosion. That was, I would say, the final stage in my rotation. And that rotation was really helpful. And I'm really grateful that I went through that program because it made me realize how interconnected everything is that we are not doing a failure analysis in silo. We are not doing inspection in silo. We are not reviewing MTCs in silo. Everything is interconnected, starting from procurement until the retirement of the asset. That life cycle requires a system in place that requires the input from different teams, from different processes. So, I mean, that experience was useful for me to understand how everything is interconnected and how one process delivers an output, and that output is being used by another process. So wearing those hats in different seats gives you that understanding and realization.
Yeah. Okay. So when it came to making that changeover, did you put yourself up to move over into that role, or were you asked to take on that role? How did that work out?
Well, I think I found my place there and I was giving good results. So, and I found my passion in corrosion, RBI, looking at failures. looking at how to improve our strategies. So I would say it was from both ways, from management point of view and from my personal point of view.
Yeah, it was kind of just the right fit. Everybody kind of realized.
Exactly.
Yeah. What do you think along the way, as you've been working and interacting with folks, what do you think's been the skill that has supported you the most? What do you think is the skill that you have that has allowed you to kind of progress as you have throughout your career?
Well, one skill that comes to mind is critical thinking and trying to think and tackle an engineering problem the right way. So when a problem happens, we should not look at it superficially from the outside. We have to dig deeper into the problem and look at the root cause. So when I'm giving a recommendation, is that recommendation really solving the problem, or is it just covering up the issue? So I would say critical thinking is one of the skills there. Also, one of the skills that I developed while my role as reviewing MTCs was to be familiar with standards and codes and material specification. That was really one of the most helpful positions, because it gave me that opportunity and that curiosity so when the material test certificate mentions one specification that they are complying with, what do they mean by that? What does that specification really mean? So that was one of the skills. I remember, for example, that accepting a test certificate was easy. You would compare the results or the statement of the certificate against our item description. If everything is matching, that's fine. But the difficult part or the challenging part was when there is some mismatch. And then I would think a lot before I would say that this certificate is rejected. Because sometimes for that, you need to go to the codes. Like, I'll give an example. In one of the cases, we requested, for example, a flange of Schedule 40, complying with ASME B16.5. So we requested Schedule 40, but in the test certificate, they don't mention the schedule, the part of the description. So I was leaning towards rejecting that certificate. But then when I went to the ASME B16.5, and I realized that by default, if the schedule is not mentioned, by default, it is Schedule 40, which is complying with our requirement. So that gave me the realization that I need to think multiple times and read through the code and material specification and be careful before I reject a certificate. So that is why that experience was really helpful for me to familiarize myself with the codes and the standards. And they are not, I would say, user-friendly, and it's not a fun read to...
Understatement of the century right there.
Yeah. I remember when I first joined during the first turnaround, and then I saw that we were doing the calculation for the minimum required thickness, and I saw how that formula in ASME section 8 was different than the one we studied in university. And I saw that the joint efficiency was one of the factors that goes into that formula. So I started asking, what is joint efficiency? And then I started reading through the ASME section 8, and it was a nightmare. It was a nightmare. That you would start in one clause that would send you to the end of the code, and then back to the middle, and then back to the beginning. The hyperlink and that's the code is really phenomenal.
Back in the old days, we used to keep this this graphic image pinned to the wall. I remember Hartford Steam Boiler used to put them out, but it was of a big pressure vessel, and it showed all those interdependencies depending upon the part. I found those very helpful, but now with computers and everything, it's a little easier. But you're right; it's important to be able to weave through the different interconnected considerations, right?
That alone is a skill, really, to be patient enough to go through all the references and the hyperlinks, going from one class to the other. That requires a skill.
And a good set of engineering practices too, and some tools to go along with that, right? Do you use 510, 570 certified type inspectors there, or do you go by a different type of certification? I don't know if it's any British or EU or other things.
No, we follow the American standards. So we go with the API certificates, with the AWS for welding certifications.
Yeah.
So part of my training, I went through the certification process for starting with the Certified Welding Inspector for AWS, and then went to the API 510, 570, 571, 580, and so on. So that's part of the program and the code that we are complying with.
Yes.
In our organization.
Which one was the least fun to get?
I would say the welding inspection.
Why is that?
I don't know. It feels dry to me. Like, although one of the roles that I worked with was welder qualification and welding procedures qualification.
Section 9.
Section 9. And again, AWS also refers to Section 9 and other APIs. But yeah, I enjoyed the 510, the 570, the 580, RBI, 571.
Yeah. The guy who was reading through Section 8 thought that the welding portion was dry. That's good. So I take it you don't do any backyard welding or anything.
No, I do.
You do?
Yeah. That's the fun part about it.
So you weld.
Yeah. What type of projects do you do?
And what type of welding?
Type of welding is flux core welding. And the most project that I'm proud of was my smoker that I used to smoke brisket and, all types of meats.
Yeah.
So tell me about this thing. Is it a barrel smoker or what? Or I mean, I always had ideas of taking a file cabinet and turning it into one. So what did you go with?
Yeah, I've seen that done before. Yeah. No, but the one I have is an offset smoker.
Okay.
Actually, as we speak, I'm curing a brisket to make a pastrami brisket.
Ooh,
Yeah. So hopefully the next weekend it will be ready for smoking.
Okay.
But yeah, it feels great to build such a device and then see it used in practice.
Yeah. So so tell me about it. So it's offset. Did you roll the barrel? Did you tell me about this? I'm into it.
So I'm not sure how do you have it in the US, but here we have the water heaters that are cylindrical.
Yep.
Okay, so I repurposed one of the decommissioned water heaters into the smoker.
Okay.
So I took one small heater and turned it into the firebox, and a bigger one that is the smoking compartment, let's say.
Yeah. And then did you buy the racks or did you weld all of the individual bars together to create the racks?
Yeah, and then for the, let's say, the structure or the legs of the smoker, then I bought some square tubes just to build the structure where it will sit on.
Love it.
And the grill itself, did you just buy that or did you build the grill too?
No, the full thing was made out of the water heater.
Yeah.
Yeah.
Wow.
Love it. That's awesome.
Yeah, that was a project that I really enjoyed. By the way, I built it during the pandemic.
I was gonna ask how long you've had it now. Okay, so we're going on 6 years, 5-6 years now.
Yeah, and still running.
Love it. Dang.
Staying at home, you become crazy, and you start building stuff that you don't know that you needed. But
very resourceful.
Really enjoyable experience.
Were you dabbling in welding work before the pandemic, or that kind of was like the thing that you were like, I'm going to learn this?
Yeah, I brought the welding machine just for that project.
Yeah. Okay.
Yeah. So that was my motivation behind going into welding.
Gotcha.
I part of our university study, we practiced welding.
Yeah.
But years after the university, during the pandemic, I thought, I saw this cool thing where you smoke meat and it becomes this tender butter that you can just devour.
Yeah.
And I was really, really impressed with the things. I'm gonna do this. So I bought the machine and built this.
That's great. I'm imagining. So I'm thinking about my water heater at my house, and it's probably 5 feet tall. How many brisket can you fit on at one time?
One.
Okay. So
one brisket. Yeah.
Okay.
The one I have was around 1 meter, so that's around 3 feet
Yeah. Yeah.
long. Yeah, so there you can fit one brisket.
One brisket in there. Okay.
Yeah, yeah.
Are there
Nice.
other welding techniques that you do in addition to flux core arc welding?
No, that is the one that I have, and
Okay.
yeah, for me that is more than.
Yeah.
I'm thinking
Yeah.
about learning TIG welding.
Yeah.
Especially for for cosmetic things. It looks nice.
Yeah, it does. They make pretty welds.
Exactly.
They lay down a good
exactly.
root pass too, right?
Yeah, yeah, yeah.
So for Brandon, for your benefit, so he's talking tungsten inert gas welding, which is where you use an inert backing gas when you're during the welding process.
Yeah.
That's cool. I want to do that. I've always wanted to learn to weld, and I just need to do it. Maybe you've inspired me here, Abdulrahman.
It's a fun skill. Yeah.
Yeah, and I think it's very resourceful. I mean, there's all kinds of things you can do when you know how to weld, right?
Yeah.
You can build,
Stuff you
repair.
need, stuff you don't need. That
Yeah.
you can.
Stuff you tell, dude.
But it sounds like something you needed with that hot water heater.
Love it. So do you take lunch over for everybody in the department? Smoke up a brisket on the weekend and slice it up and bring food in, or?
Yeah, exactly. Yeah, it's useful for family gatherings, for friends and colleagues.
What else do you like to cook? You said brisket.
It's a fun excuse.
Fun excuse. Yeah. Yeah. You like brisket.
Yeah.
What else do you cook?
I make sushi at home.
Okay.
I do, of course, grilling. I do steak on the cast iron skillet.
Yep.
Yeah. These kind of meaty meals.
Yeah.
Yeah.
Love it.
Like a Blackstone. We have those Blackstone things here, that people, the steak is really good. Just something about a steak. Even if I cook it on the grill, I'll still put it on the flat and sear it well there. Just the flavor, right, is different, and the texture is a little different. Now I'm getting hungry.
I just got for my parents for Father's Day here. They got me a one of those thermometers that connects to your phone. It's like cheating now. I mean, you slide it in, it tells me what the temperature of the grill is, it tells me the temperature of the meat, it tells me how long till it's going to be done. Then it says take it off, and it tells me how long to let it rest. I was like, this is like simple. There's no guessing here. This is great.
Well, when you go to pellet smokers, that's also another game of cheating.
Right.
Yes.
It just does it for yeah. Oh yeah. So what type of wood do you use for in your box?
Dry trees that I found in the street, I just cut them down, chop them up, and use them.
Oh, nice.
And any wild dry tree, I ensure that is dry. I'm not cutting out for the environment.
I'm curious, are there certain trees that you find impart a different flavor? Like over here, people try to go mesquite or oak or, certain other things.
Yeah, I'm not geeky to that point of selecting that.
Wait a minute.
But yeah, I know, like people, they appreciate the flavor that the wood adds to the meat.
Okay.
Yeah, but for me, any wood is good enough.
Any wood's good wood.
Yeah.
There you go. So I got another question for you. What as your career has kind of gone along here, has there been any teachers, mentors? Has there been anybody that's really helped support your career and your path that, and if there has, how were they able to support you in that?
Well, I mean, one is my management. I'm blessed to have management that are open to listen. As with any company, that we have rooms for improvement. So having that kind of willingness to listen and hear what is your opinion on things, how they can improve, is a blessing. So that is one. We have a great team that are really helpful, and they try to help as much as possible on the development and, having these kind of debates and, discussions on how things should go forward. So I'm really blessed having such a team.
Nice. Good. Yeah. Having support like that from a management team is really important to be able to help allow you to be able to grow yourself as well. So that's
Exactly.
Yeah, it's a lot more gratifying too, because you get to see some of your ideas implemented and the success that comes from them, I would assume.
Exactly. Yeah, I mean, one of the things that I learned during my career so far is how to propose change,
Mm.
because sometimes not all ideas are listened to, but they are not implemented, and for a good reason. Sometimes the organization is not ready enough, is not prepared to implement such a change. So then you start revising your ideas, and then you start asking why is the organization not ready yet. So you take a step back and you realize what is the real problem, going back to critical thinking and going to the root cause. So, for example, as I mentioned, like some companies, they will resist the idea of transforming their inspection program from a time-based to a risk-based inspection. And if you ask yourself, for a good reason, they don't have data confidence.
Mm-hmm.
So then the changes. It's no longer from time-based to risk-based. It becomes, why do I have an issue in the data confidence?
Mm-hmm.
So how can I improve my data quality? So having that kind of feedback from management and how you can improve proposals is one of the lessons learned there.
Yeah, oftentimes it's not just technical, but it's interpersonal skills and communication skills as well. But you're right on. I think you're spot on because, so often it may be because it's not in the budget or, other reasons, but it's important, I've found, to be patient, right?
Exactly. Yeah.
And understanding.
And,
Yeah.
and thinking strategically about things. So we're not trying to fly to the moon in one jump. Thinking strategically about things. What are the prerequisites of a certain initiative? So before I jump into that step, what are the steps that I need to take before?
Yes.
So it requires patience, requires strategic thinking, and also understanding about the people and what motivates them to move forward.
Yeah, a lot of times we don't think about how implementing something is going to be disruptive to the people who have to implement it and own it. And then, and of course, it's just, is the juice worth the squeeze? But you're right. You have to think about how you reward people and how it's going to affect them. Because if you just dump something on them on top of everything they've been doing already, and then don't explain the value to them and the value to the company, they're not usually going to do it, or they'll just let it slip. Right?
Exactly.
Are there any words of wisdom you'd like to share with our listeners? How you feel to become a really good inspection engineer and to be a good inspection engineer? I know you've already gone over a lot of those, but is there anything else that you feel like you haven't said that you'd like to share with us?
I would say reading and being curious is really important for some engineer that was just starting in his career. Have a plan, ask somebody to guide you on how to plan your training and what topics I need to develop and read through. Because now all the international bodies that develop codes and standards and lessons learned and technical reports such as API, Inspectioneering, ASME, like all these institutes and organizations that do that kind of knowledge retention, they do a massive effort to record that knowledge and keep it accessible for people to read through. So now we're in a time where most of the knowledge is recorded. So nobody has any excuse not to learn new things. So it's just being curious and asking the right questions, planning your training as an important strategy for somebody who's just starting his career on integrity.
Thank you. That was good.
Yeah.
So what's next for you, Abdulrahman? Right now you're a corrosion engineer. What are the next big challenges you have in front of you, if you could share them, and how you're preparing for those challenges?
Well, on a personal level, I try always to improve myself in terms of qualification, certification. I find that path to be useful to learn things in a systematic way.
Mhm.
That you have a syllabus, you have a set of textbooks that will guide you on what to learn exactly. So I hope I will never stop to learn and read. One of the steps that I'm preparing for now is to take the AMPP Senior Corrosion Technologist. So I'm preparing for that.
Awesome.
Also, as an organization, as a team, we are developing strategies to move forward. We have a lot of ground to cover. We have a lot of room for improvement. So we always have these kind of interesting discussions where we try to identify what to do next, and what to do throughout the next 5 or 10 years. So we have a lot to do. And I'm telling you, like, I'm really passionate about my job. That you can never get bored with integrity. There's always something to improve, something to do better. And I'm really blessed in this field. I never thought I would be in this position, but I am in integrity.
Yeah, to me, it's very gratifying, having been involved in inspection since the 70s, to hear people talk about being an inspection engineer. I think that's awesome. I think over the years, I've seen the profession rise in appreciation and importance, and it's because of guys like you and other ones like you that have a passion for what they do and want to do a good job, and the ability to balance both business and safety, because they need one another.
Exactly. I would like to share an experience, as you mentioned, about business and safety. Is that I remember in one of the requests that we received as corrosion engineers, that I was asked to review the essay of an opportunity crude. And as we know, opportunity crudes are cheap crudes that are corrosive. They are cheap because they are corrosive. So me as a corrosion engineer, I was leaning towards rejecting that crude because of the corrosion implication. So I went to my senior at the time, Tomas Ascanio, and he was wise enough to share with me that what is the issue if that crude is corrosive? It's an opportunity crude and we are a business.
Right.
So as long as it's not giving any safety implication, it's just a matter of finances and looking at the life cycle of that asset and that crude and what is the revenue behind processing such a crude. So for me, that was eye-opening. And going back to the systems and how we as an organization, we depend on each other and each one plays a vital role that is part of the full framework. So as corrosion, it's fine. You need to prevent corrosion. But if it gives a financial benefit to the organization, we should consider and we should be careful in our recommendations.
Yeah, agreed. Yeah, the ramifications. I mean, I'm sure it goes on all over the world, but, decisions to ally up, their equipment so that they can handle the opportunity crudes. But you're right, there are a lot of knock-on effects and ramifications that occur and can occur. And it's up to guys like you to figure out what those things are and to give management the information they need to make the best decisions, right? Because it's the long-term reliability of the equipment as well. It may not lead to immediate impact, but I think most of the failures I've seen that slipped by was because this accelerated damage occurred, let's say it began occurring 20 years ago, but it only happened maybe 2 months out of the year. And then we went to a sweeter crude and we didn't have those issues. But then 5 years after that, it's this accumulated damage that's occurring over time, and it's rarely linear. And when you go back and look at these things, well, how'd that failure occur? We were circulating sour water in this part of the loop, and it wasn't designed to see that sour water, and the corrosion rate goes up by X amount when we do that, but we only do it 3 months out of the year. But yeah, you've been doing it for 30 years now, like that. But yeah.
For that reason, that communication between departments and the corrosion engineer being part of that, with the process engineer, with the operation specialist, having that communication of understanding what is happening in the unit and how does that affect the condition of our assets.
Yeah, and the quality of the inspection data, right? Because so often I've seen people blow off high corrosion rates and, that's just an anomaly. That wasn't really happening. And later on you find out, it was happening.
Because they don't have the context. The context is not there. But when you have that kind of MOC program where You document the changes that are happening, and that is made clear to all the stakeholders of the organization. The context becomes clear to everybody, and how is that affecting the condition?
Exactly. And you just brought up a topic I'd like to hear you speak to a little bit before we conclude is MOCs. Can you give us your thoughts on the importance of an MOC program and things that we might not normally think of as something that we should apply MOC to, but, if you could speak to that a bit.
Yeah.
Abdulrahman.
As I mentioned through our discussion regarding the data relevancy, that ensuring that the data stays relevant. The MOC is a crucial tool in that regard. So going through these MOCs and reviewing your asset strategies. With this change that we are going to implement, how will that affect my inspection program, my material selection? Do I need to upgrade the material? And do I need to implement some kind of chemical program, chemical treatment? So, so I believe MOCs goes hand in hand with the IOW program and ensuring that whatever inspection findings we have builds that confidence in the data that we are collecting.
And of course, up front of that, maybe determining when an MOC is invoked or what requires an MOC too, and having that, having a corrosion engineer with an excellent inspection background involved in that and a lot of experience, I think is very valuable, very valuable.
Yeah. And so sometimes, as you mentioned about invoking or triggering MOCs, that sometimes people not realize that this requires an MOC. And then communication becomes your backup plan. Having that continuous communication with the operator, with the process engineer, knowing what is happening, what are the changes that are being done. So maybe things from their point of view doesn't require an MOC, but when you communicate with them and have a conversation with them, you can guide them that, no, this has consequences and it deserves our attention and consideration for a meeting and discussing this kind of change.
Precisely. Brilliant. I like that.
Well, anything else?
Nothing other than to thank you for the opportunity and for establishing this platform. I've been a listener to your podcast since day one. I was really thrilled when you announced the podcast. Having this kind of community that shares the same passion was interesting. And all the guests that you had on the show, they brought a lot of wisdom and insights to the podcast. So I thank you for giving this opportunity to myself personally and to the world to be accessed to these kind of information.
We appreciate it. We appreciate you joining. Now you're one of those people who's now adding knowledge to the world for everybody. So we appreciate you taking time out of your evening and sitting down and talking with us.
Thank you for having me. It's been real fun.
It was very fun, and I certainly enjoyed it. Thank you for your time.
Awesome. All right, Greg. Well, until next time. Thank you for listening to Upon Further Inspection, a Mechanical Integrity podcast. This episode was co-created by Inspectioneering and Core Solutions. Our producers are Nick Schmoyer, Jocelyn Christie, and Jeremiah Wu. This podcast is for informational purposes only and does not constitute legal or professional advice. Listeners should seek their own qualified advisors for guidance. If you enjoyed this episode, please join us next time wherever you listen to your podcasts. Until then, stay safe and stay informed.